Assalamualaikum and good day everyone. So today we are going to focus on lecture 3, which is still on 6.3 and 6.4, measure of central tendency and measure of dispersion, but still within the ungrouped data. So the learning outcome for this lesson, we are going to do the same thing as lecture 2, but the way the ungrouped data represented is different. Okay. So, measure of central tendency of frequency distribution. So, here we have the frequency distribution. It will be different from the previous type of ungrouped data. How is it different? Because for this type of data, they give you not in raw data, but in table form. So, this is how we do find the mean. So, the frequency distribution will give you the values, data, and then the corresponding frequency of each of the data. This implies x1 occurs f1 time, x2 occurs f2 times, and so on. Okay, in this case, the mean will be summation of fx divided by summation of f. So, this summation of f is the same as the total number observation in the previous type of data. Okay, the representation of raw data lah. Okay, so for median, they will be the same as the previous one, but for a frequency distribution, median is identified based on the location in the cumulative frequency. Okay, and then for mode, the mode of the data set is the value that occurs most frequent. The interpretation is the same, the definition. So it may not exist or it can be not unique lah. So how do we find the mode? We just have to look at the frequency of the data. So the most frequent, it will be the mode lah. Okay, so let's see the measure of dispersion. Okay, so we use the formula as the same as for the group data. But for the group data, it will be more step lah. Later we will learn in lecture 4. But for this type of ungrouped data, the variance of a set values which we denote by s squared, we will have to find summation of fx squared, means that the value x should be squared and then multiplied by its corresponding frequency. And then we also total up the multiplication between the f and x. Okay, so this is the formula for variance. So the standard deviation will be the square root of it. Okay, so coefficient of variation, it will be the same lah. Okay, let's see example. So example 1, the distance traveled to work by 125 commuters were measured to the nearest 5 kilometers and is summarized in the following frequency table. So what is this table means? So this distance travel, so let's say 5 kilometers, the number of commuters, the person that commute by 5 kilometers is 12%. And then for 10 kilometers, there will be 23%. So if we put it in raw data, we need to list out 5, 5, 5, 5, 5, 5, 5 for 12 times. Also for 10, we need to list out by 23 times. So it will be messier lah. So the data will be so long. Okay, so that's why we simplify into this type of table. Okay, so we know this 5 is repeated by 12 times, this 10 repeated by 23 times, 15 repeated by 45 times, 20 repeated by 32 times, 25 repeated by 13 times. Okay, so if we put in raw data, it will be like this lah. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. So we have 12 of 5. So we don't want that. So that's why we put it in table. So how to find the mean, median, mode, standard deviation, variance, comment on the skewness. Let's see how we do it. Okay, so what we need to do now to include another row of fx. Okay, so fx, we just have to multiply each of x with this, with its f. Okay, so fx and so on, and then we have to total up the f because this is in the formula of variance. And then in the formula, also in the mean formula. So what is fx? Okay, so if we calculate, we get all this value. And then we can total up, it will be 1930. And capital F is the cumulative. So we just have to total up 12. And then for the next one, we total up 23 with the previous cumulative. We get 34 or 35. And then 45 add up with 35, we get 80. And then 32 add up by 80 is 112. And then lastly, 13 is 125. So we have 125 kilometers. Okay, now we have all the data now. We can find out what is the mean. So mean, we just need the summation of fx divided by summation of f. This is summation of f or n. Okay, so directly we get the final answer equal to 15.44. So this is the mean. Okay, so later I will show you how to find out the summation of fx without finding all each values lah. So we just directly find what the total. Okay, now x bar is equivalent to 15 kilometer lah. Why? Because all the value here given in nearest 5 kilometers. Okay, so for the median, average of n plus 1 over 2. Why? Because we have 125n. This is an odd data, right? So we just have to find, for odd data, it will be 125 plus 1 divided by 2 observation. So it will be 126 divided by 2 is 63. 63 observation is equal to what? So we need to look at the table on the cumulative distribution. So which 63 observation lies on? Okay? Okay. So later we go back to the table. So how about the mode? We just have to look at which value of x that has the most frequency. So if we look at the table, we will have 15 kilometers as the results. So this is how we find out for the frequency distribution, frequency table for the ungroup data. Okay, now, so we skip to question number F because because we need to use the value of mean, median, and mode to comment on the skewness. So if we can see the result we get from A, B, C, we get that mean equal to 15 kilometers, median equal to 15 kilometers, and mode also equal to 15 kilometers. So we can say that it is almost the same. Okay, so if it's the same, then we can say that the distribution is a symmetrical distribution, which is also known as a normal distribution. Okay, so for question C, D, and E, we need to find what is the variance and standard deviation. So for variance and standard deviation, we have the value of fx squared. We need to find what is the summation of fx squared. So that's why we need to find what is f multiplied by x squared. So what is f? 12 multiplied by x squared. So 5 squared is 25. 25 multiplied by 12, we get 300. So we have to find out. So later I will show you how to find out directly the total by using the calculator. So this is how we use it, how we do it by using manually. Okay, so we have all this value and then we total up, we get 33,650. And then later we just put into the formula of standard deviation and variance. So for standard deviation, it will be square root of this formula 1 over n minus 1, which is 1 over 125 minus 1, multiply with summation of fx squared, which is we get 33,650, minus summation of fx, which is we get earlier equal to 1,930, and then we square the value divided by 120. So the answer for standard deviation is equal to 5.57. So the variance will be the square of the 5.57, which is equal to 31.05. So we have answered all the question up to F. Okay, so next example. So example 2, the number of letters received in one day in 80 houses. So we have 0 letter in 11 houses, 1 letter in 29 houses, 2 letters in 21 houses, 3 letters in 12 houses, and 4 letters in 7 houses. So we need to find all the mean, median, mode, standard deviation, variance, and comment on the skewness. Okay, now it will be the same. We need to find the summation of fx for the mean, and then summation of fx squared for the variance and standard deviation. And then for median, we need to know what is the cumulative distribution. Okay, so let's see the mean first. We need to find the summation of fx. Just multiply the x with the f. So we get the total, and then find the cumulative. So 11 plus 29, we get 40. 40 plus 21 is 61. 61 plus 12 is equal to 73. And 73 plus 7 is 80. So we have total 80 houses. So for the mean, just divide the FX, summation of FX with the N, total frequency. And then for median, okay, so we have 80 data. So 80 data is even, right? So we need to use the formula of 80 over 2 observation and 80 over 2 plus 1 observation. Find the average. So it will be 40th and 41st observation. So which one is the 40th and 41st observation? So 40th will be here. Remember, this is 1 to 11. This is 12 to 40th observation. So 40th is 1. Okay, so 40th observation is 1. And then 41st observation is the next group. 41st up to 61st observation. So 41st observation is 2. So we need to find the average. It will be 1.5 lah. So this is what we call as the cumulative. Here from 1 to 11. And then we continue from 12 to 40th. And then we continue from 41st to 61st. And then we continue 62nd to 73rd. And then we continue to 74th to 80th. Okay. So for median, we get 1 plus 2 divided by 2 is equal to 1.5. And then for mode, which one has the highest frequency? So we can see from the table is equal to 1. 1 has how many observation? 12 to 40, right? So it's 32, 38 I don't remember the frequency. You can look at the frequency from the table. So the mode is equal to 1 because 1 has the highest frequency. Okay, so let's continue with the next question. Okay, so let's us answer question for F first. Comment on the skewness. So we have the mean, median, and mode already. So if we look at the value, the mode is smaller than median and smaller than the mean. Means that it is skewed to the right. Why? Because the mean is on the right side. Okay, so we can say that the skewness of the distribution is to be positively skewed or skewed to the right. Okay, so for question D and E, we need to find out what is fx square first to find out the total of fx square. So from the total of fx square, we get 333. Okay, so substitute all the value into the formula of standard deviation, 1 over n minus 1, which is 80 minus 1. And then fx square summation, it will be 333. And then fx is equal to 135. And then square divided by 80. So we get the standard deviation equal to 1.15. And then the variance E will be the square of the standard deviation, which is 1.15 square equal to 1.33. So that's all for this example. Okay, so example 3, the last example. So we have this data, age of the accountant, salary of accountant, we have mean and standard deviation. So we want to check which of the data set is more dispersed, proved by the suitable measurements. So usually dispersion or spread of the data, we can compare by using the coefficient of variation, which is use the formula of standard deviation divided by mean multiplied by 100%. So we are trying to find by using the formula of the both data. Okay, so for the age of the accountant, we have coefficient variation equal to 6 divided by 26 multiplied by 100%, which is equal to 23.08%. And then for the salary of accountant, the coefficient of variation CV, capital C, capital V is equal to 4,000 divided by 31,000 multiplied by 100%, which is equal to 12.9%. So which one is more dispersed? So the larger value, it will be more dispersed lah. If not, then it will be concentrate. Smaller value will be concentrate, less dispersed. So the answer will be the age of the accountant. So since the coefficient of variation is large for age, the ages are more dispersed than the salary. So we have to do this conclusion for statistics. Okay, so that's all for ungrouped data. For the next lecture, lecture 4, we are going to discuss on the group data. So group data will be more focused and different from the ungrouped data. Why? Because it will be in frequency table, and then we have to find the middle point. Later we will learn together. Okay, so thank you class. So you can try to do tutorial question. So I will put a separate video for the calculator. Okay, thank you.